So this is lesson 9.2, and we're going to be using the zero product property to solve for the two x-intercepts in a parabola. So the zero product property tells us that if an equation equals 0, that one of the factors of the multiplication happening must be 0, right? So we know that either this x minus 9, this whole term here is, or expression equals 0, or 5x plus 2 equals 0. So what we do is we just set these up and we're going to solve each one. So if this one equals 0, that means that x minus 9 can be solved. And we get x equals positive 9, right? Because we're going to add 9 to both sides. So this is one possible solution. Now, if x minus 9 equals 0, we're going to solve for 5x plus 2, subtract 2 on both sides, and then we divide both sides by 5. So another possible solution for our x-intercepts is -2/5. Now, once we have these, we can begin to graph it. So we would look here, and I'm just totally eyeballing this. So one of them is positive 9. Okay, and the other one is -2/5. So we'll change the color. Here's one of the x-intercepts, because remember our factored form was the x-intercepts. And then the other one, -2/5, somewhere in here. Okay, so this is the x-intercepts of our parabola. Now, there's more that we can do, right? We could multiply these out and put it into standard form. And why would that be beneficial? Well, it would give us our y-intercept, so we could see where that is, and it's probably going to be somewhere down here, right? Because this is the other x-intercept is on the left side of the y-axis. But that's one option. You can convert from factored to standard and find out the y-intercept. And really, I know that it's going to be my last two terms multiplied, so that would be -18. So it would be somewhere down here. Now, this one isn't really friendly for graphing, and the ones that you get will be. But this one mainly just is covering how do you use the zero product property to find these different x-intercepts. And we've done that. We found that it's 9 and it's -2/5. Now we could, do some sort of we also know that the y-intercept is going to be -18, which would be way down here. So it's going to be a really kind of narrow parabola. But like I said, this one doesn't really lend itself nicely to that. So that is one thing you're going to have to do, though, is just find those solutions. And then let's see if we can find a different example here. You will need to graph. So I'm just going to take you to one of the worksheets you're going to do, which is the additional practice page. And you'll get this in class, either Monday or Tuesday, whenever you're here. So this is what we just did. We solved the equation. Notice if there's 3 different expressions with x, you're going to have 3 different answers, okay? This one we've already been kind of working on. If it's not already set to 0, you need to subtract or add or do whatever to get all of your terms into a trinomial on the left side or the right side, like this one would be, and then just factor it like we've been factoring since topic 7. So here's one where we're going to use factoring to graph this. So first we need to identify the factors of this. So we need 2 numbers that multiply to give us -8 and that add to -2. So we know that that is going to be a -4 and a +2. So our factors are x minus 4 and x plus 2. Okay. Now we know that these are the x-intercepts, and remember they're opposite of what they're written here. And we're going to see that because watch, if we solve these, right, it equals 0. This is our output, so y equals 0, so we're on the x-axis. If we solve them, we get x minus 4 equals 0, which means x is a +4. And over here, we would get x plus 2 equals 0, which means x is a -2. So this is another reason why we're seeing that what's written inside the parentheses is actually the opposite x value on the graph. And here's the mathematics behind it to prove it. So we have an x-intercept of +4 and an x-intercept of -2. Now we know the vertex is going to be the line of the axis of symmetry. So if we can just see what value would be directly in between these two, we can get a value for our x value for our vertex. 1, 2, 3, 1, 2, 3. So this value here where x is 1 is going to be where our vertex is. Our a value is a +1, so it's going to open up, but we need to know exactly where the vertex is. So when we use this value of 1 for x and we plug it in, so we're doing 1 squared minus 2 times 1 minus 8. So I'm using the original function. Evaluate this. It's 1 minus 2 is -1 minus 8 is -9. So the vertex is at 1 and -9. So here it is here. Let me get rid of this. Okay, now the fun part, we're going to attempt to connect our parabola the best we can. And that's pretty good. All right. So that's how we can graph it. And like I stated earlier, you could even, well, it's already in standard form, right? It's already in standard form, so that was nice. So you really already have your y-intercept as well, which is -8. And we can see that here, and we can see that it's been reflected on the other side. So finding those x-intercepts by solving, by factoring, okay? Then graphing those, getting the midpoint for your axis of symmetry in between your two x-intercepts, finding that vertex, putting that there, and then using the y-intercept as another point, and then it can be reflected over the axis of symmetry. Then you're going to, for these ones, you have the x-intercepts, so just write them in factored form. Okay, so it should be 2 binomials like that. Remember what's on the graph is the opposite in your equations, in your factoring, okay? And we just proved that with the math, and we've also learned that by trial and error in previous lessons. So that's pretty much it. You have a few other worksheets that you're going to get in class, this one and this one. The one where it says solve it by graphing by hand, you're going to do it the way that I just explained it in the video. And you're also getting another page, the additional practice, plus this concept summary. Okay, so it's a good note taker, hold on to this. And then this, don't worry about this right now. I think we already did that in another one, but that was from using tables. Okay, that's it. Have fun.